Profinet, or Process Field Net, is a robust communications protocol for industrial control systems. It's an industrial Ethernet-based form of communication that is used extensively by Siemens PLCs. Profinet may be used to connect a variety of devices, including PLCs, HMIs, servo controllers, distributed I/O racks, temperature or pressure sensors, and more, all on one network. One benefit of Profinet networks is that it can produce very fast response times. Response time is a measurement of the time it takes for a piece of data to travel across the network from one device to another. Faster response time means more up-to-date feedback can be gathered from devices, and more precise command signals can be given. Profinet response times vary from a few milliseconds down to only a few hundred microseconds, making it ideal for real-time motion control. With Profinet communication, real-time data is given priority over other network traffic, ensuring reliable communication between high-speed devices. Other forms of network traffic could include live video streams from cameras or other imaging devices, data transfer between the PLC and an operator control station, or communication between other networked components. Real-time data, such as that used to control servos and other motion-related devices, should always have priority over these other forms of network traffic in order to ensure safe and reliable operation. While a standard Ethernet cable may be used to connect Profinet devices, industrial-grade Profinet cables have better shielding and will provide better performance in an electrically noisy environment. Profinet devices must be assigned both a device name and a standard IP address. An IP address is an address that identifies each unique device on nearly all Ethernet-based networks. Each device on a network must be assigned an IP address in order to communicate properly. A device name, on the other hand, is used exclusively by Profinet devices to identify each other on the network. Without a device name, a device will not be recognized on the network, even if it has been assigned a valid IP address. Therefore, both a device name and IP address should be used. The most common way to assign a device name to a network device is by using PLC programming software, such as TIA Portal for Siemens devices, or a standalone utility such as Primary Setup Tool. This can be done by searching for the device on the network, connecting to or going online with the device, and then setting the desired name. Device manufacturers may also provide their own software utilities for managing Profinet devices. Be sure to consult the manual if you're unsure how to assign a device name to a Profinet device. For some devices, both the device name and IP address can be assigned by using a pre-programmed memory card, which can help to speed up the commissioning process. We'll learn more about this in another video. When selecting components for your project, be sure that all devices are Profinet compatible, that it's capable of being used on a Profinet network. Other industrial Ethernet communications protocols, such as Ethernet IP, are not compatible. If you are required to use a non-Profinet device for your project, you'll need to use a special gateway to connect the device to your network. These are available from a variety of vendors and are a cost-effective solution for adding non-Profinet devices to your network. Profinet is a powerful tool. Learn the basics, and you'll be on your way to becoming an expert in no time. A Profinet device is a device that uses the Profinet communication protocol to communicate with other network components. Examples of Profinet devices may include PLCs, HMIs, remote I/O racks, sensors, actuators, VFDs, and more. In this lesson, we'll go over these basic Profinet devices and learn what they're used for. First, let's talk about PLCs. A PLC is a programmable logic controller. It is a small, yet often very powerful computer used to control and monitor automated processes. A PLC will often be networked to other devices that it uses to collect data and perform necessary functions, such as running a conveyor or locking a guard door. Profinet is the network of choice for Siemens PLCs. HMIs are another common type of Profinet device. An HMI, or human-machine interface, may often be found in the form of a touchscreen-enabled operator panel, from which an operator can access a machine or system. An HMI may allow for both the control and monitoring of a process, as well as providing the operator with important information about the machine, such as if maintenance will be needed soon, or if an error has been detected. HMIs can be very powerful, conveying hundreds or thousands of pieces of information between the user and the PLC every second. A high-speed network like Profinet ensures reliable data transfer between the HMI and the PLC. Remote I/O is sure to be found on any large automation system. I/O stands for input-output. In order for a PLC to do its job, it must be able to collect data via inputs and send control signals via outputs. Each input or output usually requires one or more wires to be run from a component, such as a sensor or an actuator, to the PLC. In small systems, this is not usually a problem. In larger systems, however, this can result in hundreds or thousands of wires being run from the PLC out to each of the connected components. This can result in a costly and time-consuming setup process, and can complicate troubleshooting later on. In order to eliminate large and costly wire runs, a remote I/O station may be implemented at one or more locations in a system. Tens or hundreds of sensors and/or actuators may be connected to a single remote I/O station. The remote I/O station then transfers data to and from all of the connected components back to the PLC over a single network cable. This prevents unnecessarily large amounts of wire being run back to the PLC and can save hours or days of time spent building a machine. Sensors are critical process control components that may be found on a Profinet network. Sensors may be used on a machine to monitor things such as the temperature of a liquid, the level or pressure of a tank, or speed of a motor or conveyor. While standard I/O can often be used to convey this information back to a PLC, Profinet-enabled sensors may offer more advanced diagnostics, more precise information, and an overall higher level of control over your system. Actuators are another class of process control components that may communicate over Profinet. In order to do its job, a machine must perform certain functions. An actuator is a device that performs a certain movement when given a command signal. These actuators may perform tasks such as closing or opening a door or valve, pushing an object from one conveyor to another, applying a label to a product, or positioning an object. As with sensors, actuators may operate as network devices or using standard I/O, but Profinet may provide more valuable feedback and greater control than you would otherwise have. Lastly, a VFD is another device commonly found on Profinet networks. A VFD, or variable frequency drive, is used to control the speed and direction of an electric motor. These motors may be used to control the speed of a conveyor belt, the speed of a fan, or other motion-related actions. Using Profinet over standard I/O to communicate with a VFD gives you access to hundreds or thousands of feedback and control parameters. This enables very precise control of a motor and allows you to gather data about factors such as speed, torque, and other things that may provide valuable information about the condition of your motor. Diagnostic information may also be communicated to the PLC over Profinet, thus speeding the troubleshooting process if something goes wrong with the motor. Profinet devices are found in many factory and industrial environments where automation is used. These devices are used to control and monitor automation processes to ensure that personnel and equipment are protected from potential hazards, to ensure that quality standards are being met, and to ensure that machines are operating at peak performance. You might notice that the Profinet port on a device looks very familiar. Profinet networks use much of the same physical hardware that you would find on a standard home or industrial Ethernet network. A standard Category 5 or Category 6 Ethernet cable may be used to connect devices in an environment with little electrical interference, such as at your desk. In a high-noise environment, however, official Profinet cables should be used as they implement robust shielding to protect the network from unwanted electromagnetic interference. Profinet devices may be connected directly to each other, or by use of a Profinet or Ethernet switch. If you'll have more than 2 or 3 devices on your network, chances are that you'll want to use a network switch to better organize your network. If a Profinet device becomes damaged or is otherwise disconnected from the network during operation, an error LED on the PLC will usually notify the operator that a device has been lost from the network. A PLC acts as a sort of digital brain, and in addition to running the program that controls the process, it will also monitor the Profinet network and attempt to notify plant personnel that a device has been lost from the network. The PLC knows what devices should exist and will generate an error if something is missing. When a program is downloaded to a PLC, information about all network devices is also transferred. If the actual network configuration does not match the configuration downloaded to the PLC will know that something is wrong. In conclusion, Profinet devices are powerful components designed to make your life as an automation engineer a little easier. No matter the size of your project, Profinet can provide a cost-effective, convenient solution. For more details about how Profinet works, be sure to check out our next videos. What is an IP address? How is it used? What does it do? Today, we are going to learn about IP addresses and why they're important in the world of industrial automation. IP stands for Internet Protocol, and an IP address is an address used to identify a device on the Internet or on a local network. Just as a letter or a package must have a valid address on it in order to reach its destination, packets of data that are sent across a network must also have a destination address in order for the data to be delivered. If you write a letter to Grandma and forget to put her address on the envelope, the letter will not make it very far. An IP address looks very different from a street address, however. It consists of 4 separate parts, or octets. An example of a common IPv4 address for a local network could look like this: 192.168.0.1. Together, these 4 parts specify both which network and which device data is to be sent to. The first 3 octets specify which network a device resides on, and the last octet specifies a specific device. IPv4 is a standard that was used universally from the early 1980s until about 2006, when the IPv6 protocol began being used as well. Over 4 billion unique IP addresses are available using IPv4, and for decades this was more than sufficient to accommodate the number of devices connected to the Internet. However, with the introduction of smartphones and other personal electronic devices, the need arose to support more than 4 billion devices worldwide. This need culminated in the creation of IPv6, which uses a different address format and supports more than 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, 374 quadrillion, 607 trillion, 431 billion, 768 million, 211,456 addresses. That's 50 octillion addresses for each of the 6.5 billion people on Earth. Needless to say, IPv6 will not become obsolete anytime soon. An IPv6 IP address looks like this: 20001000.8C88:8:8:800C:200C:417A. In the field of industrial controls, you'll rarely encounter IPv6 addresses. A basic understanding of IPv4 addressing will be sufficient for nearly all applications. Every device on a network must have a unique address. If more than one device has the same address, an error will occur, and data cannot be properly transferred. Most devices are set to a default IP address out of the box. So, if you're using more than one of a similar device, chances are you'll have to modify some IP addresses during the creation of your network. This is true of all Ethernet, Ethernet IP, and Profinet networks, as well as most other Ethernet-based networks. For most industrial control components, the IP address will be set using the programming or configuration software provided by the manufacturer. Others, like this Turk Ethernet IP gateway, will have switches that can be used for limited IP address configuration without the need of a computer. In our last video, we learned about IP addresses, what they are, and why they're important. In this video, we'll learn more about IP addresses, how they're assigned, static or dynamic, how they're used in the world of industrial controls, and how keeping a record of your IP addresses can be helpful when troubleshooting problems. First, let's discuss how addresses are assigned. IP addresses may be static, assigned manually, or dynamic, assigned by a computer. A static IP address is set by the user and will never change until changed again by the user. A dynamic IP address, on the other hand, is an address assigned to a device automatically by a router using DHCP. DHCP stands for Dynamic Host Configuration Protocol. Using DHCP, a router will automatically assign addresses to new devices as they're connected to the network. This is most likely how your home network is configured. Once assigned, this specific address is now temporarily reserved for this specific device. If the device is briefly disconnected from the network and reconnected again, it will usually be reassigned the same address. If a device is disconnected from the network for a longer period of time, usually a matter of hours or more, the previously assigned IP address will be added back into the pool of available addresses, and the device will likely be assigned a different IP address when plugged back into the network. Most industrial control systems use static IP addresses. One reason for this is because it is desirable to have a high level of control over your network, and troubleshooting is easier if you know which device a specific address is assigned to. For example, if your HMI is not behaving correctly and you know that your HMI has an address of 192.168.0.2, you can attempt to communicate with that IP address using your computer. If you're unable to communicate with that address, even though you're connected to the same network, a network communications error is likely the cause of the undesired behavior. If you are able to reach that IP address, however, this would indicate that another issue may be present. IP addressing is a major aspect of most industrial control systems, and learning to assign and manipulate IP addresses is a must-have skill to have in your toolbox. Take the time to learn the basics of networking. The more you know and understand the basics, the better prepared you'll be to solve problems and provide effective, quality solutions for your client. Today, we are going to learn how to assign an IP address and a device name to a Profinet device using TIA Portal. To begin, you'll need to have TIA Portal opened to the project view, which looks like this. Then, you'll need to make sure that your Profinet device is powered on. Here, I have a Siemens IM151 module connected to a 24-volt power supply. I will be using this device for this demonstration, but the procedure I am about to show you will work with most Profinet devices. Next, connect your Profinet device to your computer with an Ethernet cable, as you can see here. This procedure may work with or without the use of an Ethernet switch. Now, we are ready to begin. To start, navigate to the Online Access entry in the left task card. Click the drop-down arrow to view a list of all network adapters on your computer. Find the Ethernet adapter that your device is connected to and click the drop-down arrow next to it. Now, double-click the option that says Update Accessible Devices. This process may take 10 to 15 seconds. After TIA Portal has finished scanning for devices, your device should appear in the Online Access submenu. If you experience difficulties finding the connected device, you may need to use a different network adapter or a different Ethernet port on your computer. If your computer only has one network adapter, you may need to use a USB to Ethernet adapter, such as this one, available on Amazon. You can find the link for this page in the description below the video. If your device has been factory reset or is in its original out-of-the-box factory state, it will appear with the name Accessible Device, followed by the MAC address in square brackets. If the device had already been assigned an IP address, the IP address would appear here instead of the MAC address. This is how we know that this device has not yet been assigned an IP address. Click the drop-down arrow next to Accessible Device, and then double-click Online and Diagnostics. From here, we are able to directly manipulate the connected device. To set the IP address, click the drop-down arrow next to Functions, and then click on Assign IP Address. Now, you may enter the desired IP address for this device. For this example, we will use the address 192.168.0.1 with a subnet mask of 255.255.255.0. Click on Assign IP Address. After about 5 seconds, you should see a message in the bottom task card saying that the parameters were transferred successfully. You will notice that if you double-click on Update Accessible Devices again, or just wait a few moments, the list will refresh and your device will appear with its new IP address. This is one way to verify that the IP address assignment has been successful. Next, we will set the device name. To do this, go back into the Online and Diagnostics menu, and then go to Functions and Assign Name. Here, we can specify a name for our device. In this example, I am using an IM151 Profinet Remote I/O module. So, I will give this a device name of IM151. Click on Assign Name. You should see a message in the bottom task card stating that the device name was successfully assigned to the device. Congratulations! You've just configured your first Profinet device, and it's now capable of communicating with other devices over a Profinet network. Check out the other videos in this course to learn how to make this process even easier by copying these settings from device to device using a Somatic micro memory card. Today, we are going to learn about Somatic micro memory cards. Somatic, or Siemens Automatic, is the name of Siemens' line of automation products. The Somatic product line includes PLCs, HMIs, programming software, distributed I/O, networking hardware, and more. Many products within the Somatic family utilize a micro memory card, also known as an MMC card, to perform their function. Some devices, such as S7-300 series PLCs, require one of these cards to be inserted at all times to function properly. 300 series PLCs have no internal memory for program storage. The program is stored solely on the micro memory card. For other devices, such as an S7-1200 series PLC, or a remote I/O head module, the use of a somatic MMC card is optional. For example, an MMC card may be temporarily used to copy parameters to or from a device, and then removed once the data has been transferred. Somatic MMC cards come in varying capacities. Some hold as little as 64 kilobytes of memory, and some as much as 8 megabytes. If your program is very large, a larger memory card may be needed to store it. It is important to note that in the Siemens world, both MMC cards and SD cards are used. While they are nearly identical in size and form factor, they are not interchangeable. That means an SD card may not be used in place of an MMC card, and an MMC card may not be used in place of an SD card. Siemens MMC cards are always green in color, like this one. Siemens SD cards are black in color, like this one. As a rule of thumb, S7-300 PLCs, remote I/O modules, and VFDs use the green MMC cards, whereas the black SD cards are used in S7-1200 PLCs, S7-1500 PLCs, and the latest models of HMIs. A third type of card that you should be aware of, a CF card or compact flash card, is also used in some Siemens equipment. These cards are significantly larger in size and are easy to distinguish from an SD or MMC card. Compact flash cards may be utilized in servo controllers, certain HMI models, and other hardware. Siemens SD cards have a significantly greater capacity than Siemens MMC cards, ranging from 512 megabytes to 2 gigabytes in size. The use of an SD card may be optional, depending on the application. S7-1200 and S7-1500 PLCs have built-in memory for program storage, so an SD card is not required to store the program. HMIs do not require external memory to operate. However, it is very common for an HMI to utilize an SD card to store special pieces of data, called recipes, as well as backup data. We will discuss HMI backups and recipes in another video. Let's talk about some real-world scenarios in which an MMC or SD card may be used to save time and money for you and your customers. Let's say, for example, that a customer of a machine builder requests a new feature to be added to their machine. If this feature requires a change to the PLC program, a programmer may be required to fly to the customer site to modify the program, resulting in a costly service trip. A simple 2-day trip can cost thousands of dollars in airline tickets, lodging, car rentals, etc. Rather than spending a lot of time and money to travel to the customer's location, an SD or MMC card can be prepared with the appropriate changes, and then the card can be shipped to the customer. The customer then simply replaces the original card, and voila, the update has been applied. Another scenario in which external memory cards may be used to save time and money is during machine commissioning or startup. For example, let's say that a machine builder produces 5 new machines each week. You, as the programmer, are responsible for downloading the program to the PLC, HMI, and any other related components. Depending on the size of the machine, this could take anywhere from 10 minutes to a few hours per machine. To reduce the amount of time spent starting up a machine, you decide to save the program to some memory cards at your desk before heading to the shop floor. More on this topic in following videos. Now, all you need to do is insert the memory cards into their components. Press a few buttons, and the machine is now programmed and ready to go, leaving you with more time to work on other tasks. Understanding how memory cards are used in industrial control systems is a valuable tool to have in your toolbox. Take the time now to learn how to use them so that you can save yourself time and money in the future. Welcome back. Today, I'm going to show you how to save the device name of an IM151 interface module to an MMC card. Knowing how to back up and restore the device name can save you valuable time in the field. If a device must be replaced, restoring settings from a previously created backup will be much faster than using your computer to configure the new device. To begin, you'll need to have TIA Portal open to the project view, and you'll need to open the TIA project containing your IM151 module. You'll also need to ensure that a SIMATIC micro memory card is inserted into your device. If no memory card is present, be sure to power down the device before inserting one into the device. Connect your computer to your IM151 module via an Ethernet cable and power on the device. First, let's verify that this device has already been assigned the desired name. To do this, navigate to the Online Access entry in the left task card. Click the drop-down arrow to view a list of all network adapters on your computer. Locate the Ethernet adapter that your device is connected to, and click the drop-down arrow next to it. Now, double-click the option that says Update Accessible Devices. This process may take 10 to 15 seconds. After TIA Portal has finished scanning for devices, your device should appear just below Update Accessible Devices. If you experience difficulties finding the connected device, you may need to use a different network adapter, that is, a different Ethernet port on your computer. If your computer only has one network adapter, you may need to use a USB to Ethernet adapter such as this one, available on Amazon. You can find the link for this page in the description below the video. The name of your IM151 will be displayed here, as well as the IP address. If you need to change the name, you can do so by clicking on the drop-down arrow next to your device, double-clicking on Online and Diagnostics, and navigating to the Functions drop-down menu, and then Assign Name. Enter the desired name, and then click on Assign Name. After a few seconds, a message should appear in the information task card at the bottom of the screen, stating that the Profinet device name was successfully assigned. Once you've verified that the device name is correct, double-click on Device and Networks near the top of the project tree task card. From here, you'll be able to view all of the devices in your project. Locate your IM151 module, right-click on it, and then select Write I/O Device Name to Micro Memory Card. The procedure happens instantly, and the device name is now saved to the memory card. You may wish to verify that the procedure has been successful. It is important to note that this procedure only saves the device name to the memory card. The IP address will be lost. Profinet communication only requires device names to be present. As such, you may want to make note of what the current IP address is before we continue, as the verification will involve erasing all settings from the module. To verify that the procedure has been successful, power down the IM151 module and remove the MMC card by pressing the eject button just below the card. A small flat blade screwdriver may be needed for this purpose. It is important to remove the memory card before performing a factory reset. Otherwise, the card will be erased as well. Once you've removed the card, power on the device and return to the Online and Diagnostics menu for your device. Click on the drop-down arrow next to Functions and then select Return to Factory Settings. Click on the Reset button and then click Yes when prompted for verification. The 4 lights at the top of your IM151 module, labeled SF, BF, MT, and ON, will all illuminate for about 2 seconds, and then return to their natural state. Double-click on Update Accessible Devices again. Your device should now appear as Accessible Device, indicating that the device does not currently have a name. By this, we know that the factory reset was successful. Power down the device and reinsert the MMC card. Power on the device. During power-up, the module will check to see if a device name has been saved to the inserted MMC card. If so, it will be copied to the device. In TIA Portal, double-click on Update Accessible Devices. The device should now appear with the name it had before performing the factory reset. If so, congratulations! The procedure was successful. You can now power down the device, remove the card, and use this card to assign this device name to other IM151 modules. To do this, all you need to do is insert the memory card into a new device, power it on, wait 5 seconds, power it off, and remove the card. As you can see, this can greatly speed up the process of assigning device names, and it eliminates the need of a computer for this purpose. In this video, we learned, number 1, how to set a device name. Number 2, how to save. The purpose of this video is to 1. Demonstrate the process of assigning a device name to a Profinet device using a micromemory card, and 2. Demonstrate that a Profinet device can communicate with a PLC using only a device name. Here, we see an IM151 head module connected to a bank of I/O cards to form a distributed I/O rack. This module has been factory reset and currently has no device name or IP address. Let's power up the IM151 module. You'll notice that the BF light on the IM151 module is blinking red, and that the SF lights on many of the other modules are solid red. This indicates that the rack is not communicating with the PLC. Let's power down the module and insert a micromemory card that has a device name saved to it. Then restore power to the module. After a few seconds, the BF light stops blinking red and the other SF lights all turn off. This indicates that the rack is communicating with the PLC. As we saw in the last video, only the device name is transferred from the memory card to the device during this procedure. The IP address is lost. As we can see, the device is still able to communicate with the PLC even without an IP address. Now, we can remove power to the rack and remove the MMC card. After restoring power again, we see that the rack is still communicating with the PLC, which indicates that the device name was successfully copied from the memory card to the device.